So I'm Alberto, and you can call me Albert. I'm from Spain. Today I'm going to speak about SOQL, Performance Explained. That's me. You have here my contact details, my Twitter and my mail. Please don't hesitate on using them and asking me anything that you want, and I will try to answer you as soon as possible. I'm a senior developer in Financial Force. Financial Force has the #1 ERP on Salesforce platform. We have more than 700 employees currently. And we are looking for new employees. If you are interested, tell me later. And we have more than 1,400 customers in more than 34 countries. That is the end of my advertisement, so let me start. I broke up my presentation in several points. First of all, I'm going to give an introduction. I'm going to use an analogy to clarify or to try to clarify all the concepts related on how to improve the performance in your queries. Then I'm going to speak about the query optimizer, how the query optimizer works. We will continue speaking about the indexes. What is the indexes that Salesforce create automatically for us? And how can create a new one indexes, and what is the allowed fields. We will continue speaking about the selectivity, what is a selected query, what is a selected filter, and what is the exception that we have to avoid when we are writing a query. And then I'm going to try to do a demo to clarify all these concepts related to the selectivity. And in the end of my presentation, I'm going to give you a couple of new tools to improve the performance in your queries, like the sort optimization and the skinny tables. And then I'm going to give the summary on all the tips that I'm going to provide you during this presentation. So let me start. When I started to prepare this presentation, my first consideration was how to explain it in 30 minutes in order for you to live with a good understanding on how to perform your queries. And I don't like to follow the definitive guides or promote the golden rule to achieve something. I think that there are many ways to do something and do it well. So I had a moment of inspiration where I decided to use the ship analogy. So try to think about the captain of a ship. He can steer his ship following many routes to arrive at a certain point. He uses a compass to guide him and a navigation chart to warn him about the obstacles that could sink his ship. In the same way, I'm going to provide you with some tools to help you to improve the performance in your queries, and I'm going to advise you about the obstacle places or things that you have to avoid when you are writing a query, because you could sink your query. But first of all, I'm going to explain how the query optimizer works. Okay, it's not the main goal of this presentation, try to understand how the query optimizer works. It's the tool that Salesforce uses for create the query and then execute in the Oracle. But to be a good Formula 1 driver, it's necessary to know how the car engine works. For make efficient queries or to be a good programmer, I think that it's necessary to know how everything works at a low level. So the query optimizer follows the following flow. First of all, sample queries. In this step, it would check the user visibility and the filter selectivity, then set the best index for execute the query, determine what is the best table from where run the query unless there is a good index available, then sort the rest of the table to minimize the joins, minimize the cost, then continue including the foreign keys to make efficient joins, and we will continue, or it continues, including the sharing joins to minimize the inputs and outputs from database. And in the end, update the statistics. Because of the Salesforce platform nature, the platform stores its own statistics to help to the database later to choose the best way to access to the data. And this statistics is stored nightly. So Query Optimizer, or Salesforce platform, organize the information more or less in that way. And bear in mind, or take into account here, that the standard fields and custom fields are in separate tables for standard object. And we will retake this issue later because I'm going to provide you with a tool to try to join all this information in just one table. So multi-tenancy is a means of providing a single application to multiple organizations from a single software hardware stack. And Salesforce store all the information for all the virtual tables in a few large database tables, partitioned by tenant and serve as a heap storage. And to data to be set, it must be first indexed to run or to execute efficiently. And that indexes are created using the search engine server, which also manipulates or manages all the queue entries for all the newly created and modified data. And as I love the analogies, I'm going to use another analogy now. So Salesforce split the information for a table in separate tables, one for the data table and another one for the index table. And try to think, for example, when you are looking for something in a book, you don't try to read page by page, look up, for example, where a chapter starts. You usually use the book index. You go to the book index, search where a chapter starts, and this index redirects you to the appropriate page. In the same way, the database works similar. So when we are trying to search some record in a database, the more efficient way is look for or search that record firstly in the index table, and that index table redirect you to the appropriate records in the data table. And bear in mind that Salesforce index null values by default for the standard objects, but for standard fields, standard indexes. But if we want to index a null value for a custom field, we can ask to the Salesforce support to enable or index that null values, but by default it's not indexes. Because that is, and bear in mind that issue, because it's another thing that we'll retake later. So Salesforce create automatically for us all that indexes. ID, name, owner ID, created date, and system of the stamp are standard fields, and therefore are standard indexes. And master retail, lookup, etc. will be indexed independently, whether they are custom field or standard fields. And what would it happen with the rest of the fields? Okay, keep calm, don't panic, because we can ask to the Salesforce support to create an index for any fields except these ones. So we can index multi-select pick list, text areas, either long or rich, encrypted text field, and non-deterministic formula fields. And what does non-deterministic formula field means? Okay, a formula field is non-deterministic when its value depends on another value. For example, today is a dynamic date, dynamic time function, and its value is continually changing. So the platform can be realistically maintained, index a value, which value is continually changing. So the most common example of non-deterministic formula field are those ones. Use of time or the dynamic function or reference to other formula fields or to other entities. And I highly recommend you that before to use a formula field to embed a hard logic in your query, try to read the documentation that Salesforce provides about this topic to consider if your formula field is deterministic or not, because depending on that, you can later index that value or not. And that is my tip. Instead of embed your logic in a formula field to use later in a word clause, try to use or embed your logic in your queries, in your report, and in your list views. For example, instead of use the today function here, we can use the last n days function and comparing with the close date. And in that case, we can use, for example, the standard index close date we can execute our query efficiently. So, as I mentioned at the beginning, I'm going to retake the analogy again, the ship analogy, because that is our best tool, it's our compass. We should use to execute our queries efficiently, because a query will run efficiently if we have an index available. A query is selective if it has at least one selected filter. And what is a selected filter? Okay, a filter is selective if it has you have at least one index in your word clause, and that index follows with the condition or comply with the condition of selectivity. The thresholds that Salesforce define depending on the kind of index, standard or custom, or the kind of operation, compose index, index onion, or like. I'm going to spoil you because the like is not our friend. So, starting with the game of numbers. A standard index, it will selective, it complies with these rules. It returns up to the 30% for the first million of records, the 15% of records after that first million, and it returns up to 1 million records. You don't have to memorize all these numbers, just me, because I have to present. You can use the sheet or retake or look this information when you need. And for the custom index, it's so close. But in that case, we can return the third of the standard index. Is the easy way to memorize. Because in that case, we can return up to the 10, the 5, and the third of 1 million records. We will see later all these numbers with the demo to try to clarify the concept. And what would happen with a composed index, union index, or like? So the query optimizer considers to use a composed index if it complies or follows these two rules. Comply with the twice of the selectivity threshold for its filter, and follow or comply with the selectivity threshold for the intersection of these fields. So, for example, try to think that you have a query with two standard indexes. So you can return up to the 60% for each filter, the 30% for the first million, the 50% for the rest of the millions, and it returns up to 2 million of records. But in the intersection, you can comply with the condition of selectivity. And the union is similar, but in that case, we can to follow the selectivity threshold always for each filter and in the union again. And the like, okay, the query optimizers considers or check the first 100,000 records and consider to use that index always that the comparing text or the string is not starting with a wildcard. And retaking again our ship analogy, that is the obstacle that could sink our query. Because I'm going to speak now about the exception that we have to avoid when we are writing a query. Because when the query optimizer finds one of these exceptions, doesn't consider to use the index. And what will it do? Okay, the query optimizer will execute our query doing a full scan, reading all the data table, and that is a bad issue, okay? So using wildcards in your queries is one of the exceptions or something that can slow the execution of your query. So take into account or bear in mind that in report and list views, the contains function is translating our wildcard string wildcard. So try to avoid use contains function in your reports and in your list views also. For me, the tip here is when you need to use wildcards, use SOQL. The another language that Salesforce provides and is more recommended for this kind of queries, the Sales Object Search language. Another exceptions, using negative operators with filters like don't, like distinct, not like, exclude, etc. is another thing that the SafeForce stop to consider to use your index to execute our query, to execute your query. So retaking again our book index analogy, try to think, for example, that you are looking for a value or a chapter which is value is distinct to some value. You have to read all the book index. So in the same way, if you have to read all the index table, and it's so probable that you have a relationship one-to-one between your index table and your data table, the query optimizer says, okay, I don't care, I don't read the index table, all the index table, so I'm going to read or search your records in the data table directly. So use filter with equals or in operators, okay? And for example, instead of writing a query like get the cases where status is distinct from close, I can say get the cases where status in all the statuses distinct from close. And in the second example, we can use the index from the status field. Another exceptions that could sink your query is comparing text field with these forbidden fields. And the example is the same. So avoid comparing text field with this kind of operators. And the last one is comparing with null when that value is not indexed. So as I mentioned at the beginning, the standard field has the null values indexed by default, but the same that don't happen with the custom fields. So when we are comparing a custom field with a null value, we don't have the null value index for that field. The query optimizer will execute our query doing a full scan. And I'm going to see now a little demo. So I've created a bunch of data. I have stored 100,000 records in the opportunity object. And here we have two aggregated queries. One for my stage name, custom field. And here we have another aggregating by close date with the week in year and the calendar year for that day. So the first thing is that SafeForce provides us with a helping tool, the Query Plan API. And we can enable here in Help, Preference, and click on Enable Query Plan. And when we do that and save, it appears here, another button, the Query Plan API. And we can use that button to try to understand what is the decisions that SafeForce or the query optimizer considers to execute our query. So first one, I'm going to set the opportunities where close date is the current week. So in that case, it's so probable that we are going to return between 1,000 and 3,000 records. So it's below or it's lower than the 30% for the first million of records, and we comply with all the conditions of selectivity for a standard index. So if we execute the Query Plan API, yeah, that is the information that the Query Plan API said us. Because that is all the decisions or all the considerations that the query optimizer considers to execute our query, ordered by default by the cost, and it's so probable that the query optimizer run our query using the first one. And in that case, the cost is very, very low comparing with doing a full scan. And all the costs lower than one will execute our query efficiently, so we can try to reach a cost lower than one. In that case, the best way to execute our query is doing a full scan, using the index in close date. But what would it happen with this another one? In that case, we are returning more than the 30%, and using an index is worse option than execute our query doing a full scan. And the cost is higher. So we don't comply, don't follow the condition of selectivity and say false, or the query optimizer will prefer to execute our query reading all the data table. Another example with a custom index. We are looking for here the opportunities where my stage name is proposal and price quote. And proposal price quote has lower records than the 10% of the first million. So it's lower than 10,000 of records. So if we execute our query with the query plan, again, we comply with the condition of selectivity, the cost is lower than 1, and will be better execute our query using the index than read all the data table. And in this another case, prospecting has more records than the 10%, and that's why execute our query doing a full scan is a better option here. I take into account that, bear in mind, it's so important because the cardinality is not very correct. We have more than lower than 15,000 records and more than 10,000. You have to remember that the query plan API is just a helping tool and is not very precise. So if you want to know exactly what is the number of records for each kind of value, use aggregated queries instead of use the query plan API. And now I'm going to see some of the exceptions. For example, first one, I'm going to compare a custom field with a null value. And the index is not appearing as an option to execute our query. And in the notes appear explanation about that. And the same happened with the rest of the exceptions. In that case, again, the index is not considering to execute our query. So the query optimizer will execute our query doing a full scan. And here, it appears the explanation, because the operator is not optimizable and the filter is not owner optimizable. And comparing a text field with a, for example, lower than or equal. Again. And the last one, okay, remember, the like is considering to execute our query or consider to use the index with a like operation, with a like operator. But as we are going to see, the cost is crazy. Okay, so don't compare like with a wildcard because it's so probable that you finally execute your query doing a full scan. So now try to think that you are in a scenario where you can reach your condition of selectivity for your indexes. You create the more appropriate index for some fields, but you can reach the condition of selectivity. So in that case, we can use the sort optimization. That optimization consists in use on order by an index field. And the first two questions that everyone asks themselves, including me, when we see for first time this kind of optimization is, okay, but if I include an order by and increasing the threshold for index, no, it doesn't. But including an order by will increase our execution time because we have to order all the results after to get all the records from the database. No, it wouldn't. The answer of both questions are no, because when we order by an index, we are telling to the query optimizer to start to analyze from the top or from the bottom of the table, because the index table are ordered by default. And when we use an order by bound with a limit clause, we are telling to the query optimizer to stop to analyze our records from top or bottom of the table and start to include all the records and when the limit is reached, it returns all the records and stops to execute or to search more records. And it's so probable that you have a limit clause in your query for not hitting with our worst enemy, the governor limits. And some consideration that we have to bear in mind when we use the sort optimization. Only works for number and date fields. When we use a two-column index, we have to filter for the first one using an equal operator and excluding the null values, and sort by the second one, and consider or evaluate the optimization. I can think in two scenarios where this optimization doesn't work pretty well. The first one is your limit is greater than the record that you return at the end, so you have to read all the index table. You are not improving anything. Another scenario is that you are looking for records that is not close from bottom or the top of the table, so you have to read a lot of records before to return anything. And if you are in a scenario that the sort optimization doesn't work also, okay, maybe the skinny table could help you. The skinny table is our friends. So as I mentioned at the beginning of this presentation, Salesforce split or store the custom field standard fields for a standard object in separate table. But we can ask to the Salesforce support to enable and create a skinny table for us and join all this information in just one table. So we are minimizing the number of joins because we have all information in just one table. So we are improving the performance. Another thing is that the skinny table is synchronized by default with the source data. We don't have to do anything. So when we are storing some field in account, for example, in that picture, is stored also in the skinny table. And the last is that the soft deleted records are not considered or are not included in the skinny table. And that is important because when we remove or do a soft delete in an application, it's another record that the query optimizer consider to calculate the limits or the threshold for our conditions. So consider the active records that we have in our application and the records that we have in the Salesforce bin. So it's important because it's more or it's easier than for us reach or comply with the condition of selectivity and use an index. But as Spiderman knows, a great power carries with a great responsibility, and there is some risk that we have to take into account. First one, the skinny table should be skinny. The maximum number of fields that we can have is 100 fields. When we modify the field type in the source, for example, we change a date field for a number field, we have to recreate the skinny table, and it's not copied by default in the sandbox org. So when all is fails, use a skinny table. And that is the summary of my recommendation. And the last one is the best way to lose weight is avoid gaining it in the first place. So it's very important that you try to get as less records as you can. So if you don't need some information in your application, you are not working with that data, try to do a hard deleted or move to another third-party database because it's easier to reach the condition of selectivity and the query optimizer consider to execute your query using the indexes. Okay, and that's all. So, thank you. Is there any question? Yeah, you can use, yeah.
So on the skinny tables, can you do that in a managed package as well? So if you create it for your custom object, would that translate into?
No, for custom object, it doesn't work because remember that we are doing with a skinny table is join the information. The standard fields and custom field is separate table are in separate table for a standard object. And with the skinny table, we are joining all this information in just one table. I think this is more appropriate or is oriented to use with standard objects.
Just standard objects, yeah.
Yeah,
And then the other is in your condition on the, say when you do a not in, is that as bad as doing different than null? Or
Sorry?
so in one of your things to not do was do the, exclamation, different than closed, right, as a clause, and rather use the in and then prospecting, and use the in clause rather than the negation of the not equal.
The negative operators.
Correct.
Yeah.
Does that apply to not in as well?
No, the not in is another negative operator.
Got it. Okay.
Because you have to read all the table also.
Okay, so just avoid not or
Yeah.
Hey.
Hi.
What is the recommendation on the null check? Sometimes we can't avoid null. So is it okay to use null and not null on indexed fields?
Sorry, could you repeat?
The null checks,
The?
Null.
The null values.
Yeah,
okay.
null values. So the question is it okay to use on indexed fields? If the field is indexed, can we have null check?
Sorry,
You still didn't get it.
Sorry.
Si tienes un null y tienes un index, ¿qué es lo que pasa? Que a veces tiene mucho.
Yeah, if you have null values with your indexes, as your question, what did happen?
Right.
Okay, as I mentioned, the null values are indexed by default for a standard object. So there is no problem if you have null values in your standard object and comparing with null. There is no problem with that. Okay? But the problem is that you are comparing null values in a custom with a custom index. And that custom index doesn't have the null value index, because in that case, the query optimizer will execute your query doing a full scan. But there is no problem with a null. Yeah, maybe the problem is that you are comparing with a null and you have a lot of records. Okay, you have to comply again with the condition of selectivity. So if you don't reach, for example, the 50% for the first million and so on, your index will not consider to execute your query.
Okay. Second question is, when you use multiple conditions like join, does the order matter, like the order of operations?
What condition?
Like we can have a select query with multiple filters, right? So like, created date this week and something. So we have like multiple conditions.
If you have multiple conditions,
so my question is,
like the compose index or union index. Okay.
So can we flip
I can show you an example with that. For example.
Right. Yeah. Right. So can we flip that? Can we flip the condition?
Yeah, there is no problem because
No problem?
the query plan API or the query optimizer considers three cases in that case. One is using the index for close date, one the index for my state name, and the other option is considered to use the composed index.
Okay.
So is another option to try to use your indexes to execute your query. Okay. But remember, here, for example, the my state name is considering to use the first up to the 20% for the first million of records, and stop to analyze because the sum for prospecting and qualification.
Right.
Okay, is greater than the 20%, and when this limit is reached, stop to consider to use the custom index my state name, for example. So when you are using a compose index, is another consideration that, for example, the query optimizer consider to execute your query.
Okay. Thank you.
Okay.
Couple of questions. What is the unit of cost here?
The
So,
the cost?
Yeah. How is it computed? What is the unit?
I don't know. I don't have this information, but if you leave me your mail,
Sure.
I'm going to back you.
Okay, sure.
Later.
And my second question is not related to SOQL, but then I'm curious to know whatever performance-related points that we discuss, does it apply to Salesforce reports as well? Like if I create a report with not null versus null, negate versus non-negate, would it also affect the report?
Yeah, I think that, for example, if you are working with a report or list views, is another information that you are trying to retrieve for your database. So it's translating with SOQL and execute in the Oracle. So you have to follow these tips also for reports and list views also.
Got it. Thank you.
Okay. So, yeah.
Question, can you use hints when writing your SOQL queries or?
Hits?
Hints, I'm coming from, for example, Oracle. Sometimes in your query you can tell it, use this index or use that index. So you can do that in SOQL.
I don't have this information right now, but
okay.
The same, if you let me your mail. But you don't have control about on the database. You can do a partition, for example, a table, or do some things that you have to do, or you can do when you are working directly with the database.
Yeah, that was the question. Partition, sometimes hints, sometimes. So some of those things you can do it with SOQL, with SOQL. When you do like the window functions or
the offset.
The offset, partition
by.
Yeah,
I think that you have these functions also in Salesforce.
Okay, thank you.
Just a quick question. So if we have custom tables,
if
we have custom tables, 2 or 3 custom tables, there is no concept of skinny tables in that case, right? We cannot create a skinny table.
If you have
custom objects, sorry.
Custom objects. Yeah. I think that the skinny table is oriented to join all information that you have for a standard object in separate tables and join all this information in just one table. But let me your mail because I'm pretty sure about that, but I'm going to confirm.
Yeah, because if you strictly look at the databases, you can create views where you have multiple tables, you create a view. So I'm just trying to figure out if the option is to join these tables, the standard objects in a query.
But
is there a better way?
Okay, the skinny table has something that improves your performance. The first one is that you have all information in just one table.
Right.
The second one is that you don't have the information of the soft deleted records in your skinny table. It's easier that you read. And another one is because the skinny table are skinny, the limits that you have is greater than you have in a common table, in a common object. Okay. So that is the thing that you get with the skinny table.
Thanks.
When you want to create or ask to the Salesforce support, because you can create a skinny table, therefore you can ask to the Salesforce support to create a skinny table for you. So Salesforce support has its own statistic about the use that you have of your objects, and you have to discuss with him because you have to your requirements. You have to discuss what is the more appropriate records or fields that you want to include in the skinny table, and in the end, they create for you.
Okay, thanks.
They will create. Okay. So, thank you.